Hello. So we start new chapter which is plane wave at boundaries and dispersive media. We have already discussed these two topics. First, boundary condition for electric wave or electric field, and second, boundary condition for magnetic wave or magnetic field. In case of electric wave or electric field, we have to take total three different cases. The first case, if both the medium is dielectric medium. Second case, medium 1 is dielectric and medium 2 is conductor. Third case, medium 1 is free space and medium 2 is conductor. Okay, and then we have discussed about the magnetic boundary condition. Okay, now we have start our third topic, which is reflection of uniform plane wave at normal incidence. Okay, so what do you mean by the normal incidence? Normal means it is known as perpendicular. Okay, that means the wave is perpendicular. Okay, that means the wave is incident at a 90-degree angle. Okay, so it is known as reflection of UPW, uniform plane wave at normal incidence. Okay, so we have considered that electric field is present in X direction, magnetic field present in Y direction, and the propagation direction is always Z direction. Okay, so here this one is our figure that X, Y, and Z. Okay, so electric field is present in X direction. Okay, magnetic field is present in Y direction, and the propagation direction is Z direction. Okay, so actually it indicates the direction of propagation. Okay, Z direction is indicate direction of propagation. Clear? So electric field is present in X direction and magnetic field is present in Y direction, and the propagation direction is Z direction. Okay, so here it is electric field, which is known as EX0. EX0 is a maximum value. Okay, it is also EX0, EX0. EX0 is a maximum value of electric field, and here it is EY0. Okay, sorry, HY0. So HY0 is a maximum value of magnetic field, and this one is known as propagation direction. Okay, so wave, both the wave are propagate in which direction? In the Z direction. So we can say that the power of electromagnetic wave is also in the Z direction. So we can say that the power direction is also Z direction, or the propagation direction is also Z direction. Okay, so the propagation direction is perpendicular to the direction of electric wave and the direction of magnetic wave. Okay, under which relationship? The relationship is the propagation direction is the cross product of the direction of electric field and magnetic field. Okay, just for example, for a simple understanding, if electric field here is present in X direction and magnetic field is present in Y direction, so what is the direction of propagation? The propagation direction is Z direction, because X cross Y is Z. Okay, for example, suppose electric, okay, is one just example. One example, suppose electric field is present in Y direction. Okay, magnetic field is present in X direction. So what is the propagation direction? Okay, so we have to just apply this formula. So here the propagation direction is E cross H. Okay, so E is in the Y direction, H in the X direction. So direction of P is, it is actually reverse X. Okay, so the direction of propagation is minus Z direction. Okay, so using this cross product you can find out the propagation direction. Clear? Okay, so now in this calculation we consider this one is my Z axis, it is my X axis, and this one is my Y axis. in a 2D dimension. I would draw this figure in this 2D page, okay, but I want to draw the same figure in 3D. So is it possible? So it's not possible, but still we want to draw this figure in a 3D. Okay, so now see here, I have to draw Z axis. Okay, here is X axis. Okay, and now the main thing, where is Y axis? So this X, Z, so this span is indicate, okay, this span is indicate this one is my Y axis. Okay, so X axis, Y axis and Z axis. This axis is negative Z axis, this axis is negative X axis, and here the bottom, that means the axis which is inside this page, it is negative Y axis. Okay, so this span is indicate this axis is a which axis? Y axis. Okay, which is point out. So this one is my Y axis, which is out of page. So positive Y axis is out of page and negative Y axis is inside the page. Okay. So here this plane, whatever the plane, okay, suppose I have to put one plane here. Okay, so this plane is known as which plane? This plane is known as Z is equals to 0 plane. Okay, so whatever the plane that I have to put here, okay, this plane is known as Z is equals to 0 plane, and this portion is positive Z portion, this portion is negative Z portion. Okay, so now we assume the wave is coming from negative Z axis, okay, and strike here, strike, suppose this one is my medium 1 and this one is my medium 2, so wave is propagated from medium 1 and the front portion of the wave is transmitted to the second medium and the rest of the portion of wave is reflected back in medium 1. Okay, so there are the three waves. First is incidence wave, second transmitted wave, and third is reflected wave. Okay, so I have to consider one plane. So this plane is nothing but which plane? Z is equals to 0 plane. Okay, so I have to take one plane here, and this plane is known as Z is equals to 0 plane. Okay, again I have to draw one axis. Okay, this negative x-axis minus x-axis. Okay, this one is minus z-axis. Okay, no need to draw minus z-axis. Okay, so this plane is known as Z is equals to 0 plane. Okay, so this portion is negative Z and this portion is positive Z. Okay, so we can say that this one is my first medium and this one is my second medium. Okay, so it is medium 1, this one is my medium 1 and this one is my medium 2. Okay, and each and every medium has total 3 properties. Which are the 3 properties? Conductivity, permittivity and permeability. Okay, so this medium 1 has 3 properties: conductivity, permittivity and permeability. Similarly, this medium 2 has a 3 properties: conductivity, permittivity and permeability. Okay, so now how much portion of electromagnetic wave is transmitted into the second medium and how much portion of the electromagnetic wave is reflected back? It depends on this material property. Okay, suppose here the electromagnetic wave is coming, okay, and it strike this Z is equals to 0 plane. Some of the portion of the electromagnetic wave is transmitted, okay, it go into the second medium and some of the portion is reflected back. So how much portion is transmitted and how much portion of the reflected back is depend on the medium property or the material property. Okay, so how much portion is transmitted? It is known as transmission coefficient. How much portion is reflected back? It is known as a reflection coefficient. Okay, so in today's lecture we have to discuss about the definition of reflection coefficient and transmission coefficient. Okay, so the question may be asked in this way: derive the equation for transmission coefficient and reflection coefficient, or what is the relationship between transmission coefficient and reflection coefficient. Okay, so now here electric field is present in the x direction. Okay, so just okay, so first I have to draw incident wave and then I will draw a transmitted wave and final reflected wave. Okay, first incident wave, then transmitted, okay, incidence wave, transmitted wave, and the reflected wave. Okay, so it is medium 1 and medium 2. Okay, so now electric field is present in which direction? In the x direction. So this one is my electric field, incidence electric field. I will just draw a arrow. No need to draw the sine wave, okay, because it is difficult to draw the sine wave for the transmitted, for incident, transmitted, and the reflected. So I will just draw a arrow. Okay, so this one is my electric field or electric wave, is an incidence wave. So this EI. Okay, what is the direction of H? H is in the positive y direction, in this direction. Okay, so this one is the direction of HI. And which one is the direction of propagation? Propagation is in the Z direction. Okay, so this is Z. AZ is the propagation direction. Okay, so it is known as incident electric and magnetic wave. Okay, so some of the portion is transmitted inside the second medium. Okay, so some of the portion is transmitted in the second medium. So I will draw this a transmitted wave ET. Okay, so we have to assume the transmitted wave is in the same direction of the incident wave in the x direction, transmitted wave is also x direction. Okay, what about the transmitted magnetic wave? It is also in the y direction, so this HT. And which one is the direction of propagation? The propagation direction is same way as it is a Z direction. Okay, so actually this type of incidence is known as normal incidence. See, it is known as normal incidence. What do you mean by the normal incidence? Normal incidence means it's a perpendicular incidence. How it is perpendicular? So you can observe this one is the propagation direction, and this propagation direction is directly perpendicular to Z is equals to 0 plane. Okay, it is directly perpendicular to the Z is equals to 0 plane. So that is why it is known as a normal incidence. Okay, so this one is incident electromagnetic wave, transmitted electromagnetic wave. Now I will draw reflected electromagnetic wave. Okay, so some of the portion of electric field is reflected back, and we have to assume electric field in the same direction if it is reflected back. Okay, it is in the x direction. Okay, so this is reflected, so this ER. Okay, E small subscript R, ER, reflected wave. Okay, now which one is the propagation direction? The propagation direction is minus Z direction. Okay, the propagation is minus Z direction. So now which one is the direction of magnetic reflected magnetic wave, which is HR, reflected wave. Okay, see here the propagation direction, here the propagation direction. Okay, the propagation direction is minus Z direction. Electric field in x direction, so magnetic field in minus y direction. Okay, so here okay, this pen is indicate the positive y direction. Okay, that means it is outside of the page. Okay, so the reverse direction is known as inside of the page, means it is negative y direction. So this cross. Okay, so here reflected magnetic wave is in the minus y direction. Okay, so this one is the normal sketch of reflection of uniform plane wave at normal incidence. Okay, clear? So now okay, so we will derive the equation of transmission coefficient and reflection coefficient, okay, for electromagnetic wave. Clear these things. Okay, so this EI and HI, okay, these both are incidence electromagnetic wave, transmission of electromagnetic wave, and reflected electromagnetic wave. Okay, so we know that electric field, okay, we have to derive the wave equation in last chapter. Okay, so electric field and magnetic field both are function of space and time. Okay, so for electric field it is E of vector E of zt is equals to E0 e raised to minus gamma z e raised to j omega t ax. This one is the equation. Okay, but here we have considered the time average wave. Okay, that means our wave does not depend on time, it only depends on space. Okay, so this is our assumptions. So we have to take this equation E of z is equals to E0 on this space term e raised to minus gamma z into ax. E raised to j omega t terms we have not considered, because here we have to assume the field is only has a space quantity. Okay, the field is a function of only space. What is gamma? Gamma is known as propagation constant, which is alpha plus j beta. What is alpha? Attenuation constant. What is beta? Phase constant, right? Okay, so now I have to write the separate equation for, I have to write here the separate equation for incidence wave, incidence electric wave, incidence magnetic wave, transmitted electric wave, transmitted magnetic wave, and reflected electric wave and reflected magnetic wave. Okay, so first I will write the equation for incidence wave. Okay, first equation. What is our ultimate goal? Our ultimate goal is to derive the equation of transmission coefficient and reflection coefficient. Okay, incidence wave. So incidence wave EI of Z, EI subscript is known as incidence wave. Okay, is equals to, I use the same equation. Okay, EI 0 e raised to, okay, if the wave is incidence, so it is present in which medium? If the wave is incidence, so it's present in the first medium, medium 1. So it's a gamma 1. Gamma 1 is a propagation constant for the first medium. Okay, and what is the direction of E? Direction of E in the x direction. Okay, what about the HI of Z? HI of Z is HIO e raised to minus gamma 1 Z. Direction of H is y direction. Okay, so we know that E is equals to H into eta, where eta is known as intrinsic impedance for the medium. Okay, so we can write H of Z in this way also. It is N1 e raised to minus gamma Z into AY. Okay, we can write in this way also. Clear? So it is the equation for incidence wave. Okay. So next equation for reflected wave. Okay, or transmitted wave. Okay, equation for transmitted wave. Okay, so transmitted wave is present in which medium? Yes, transmitted wave is present in medium 2, in medium second. Okay, so this ET, T subscript is for transmission of Z is equals to ETO e raised to minus gamma to Z AX. Okay, similarly HT of Z is equals to ETO divided by intrinsic impedance for the second medium, which is eta 2 e raised to minus gamma to Z in which direction? In y direction. Okay, and last, number 3, equation for reflected wave. Equation for reflected wave. Okay, so here reflected wave R subscript indicate it's a reflected wave. Okay, it is R0 is in which medium? The first medium, but the propagation direction is, okay, for the reflected wave, what is the propagation direction? The propagation direction is minus Z direction. Okay, so here it is e raised to minus gamma 1 minus Z, minus gamma minus Z, so it is a plus. Okay, Z AX. And what about HR of Z? HR of Z is E-RO upon eta 1 e raised to gamma 1 z into ay, and this field is present in which direction? The magnetic field is, the reflected magnetic field is present in the negative y direction. Okay, so this minus ay. Okay, clear. So these are the equations for incidence wave, transmitted wave, and the reflected wave. Okay, so here in the first medium there are two electric wave is present. First, incident and reflected. There are two magnetic wave is present, incidence and reflected. In second medium, only one electric wave is present which is transmitted, and only one magnetic wave is present which is transmitted magnetic wave. Okay, so we can write in this way. Here the total wave in first medium, which is E1, is equals to incidence wave plus reflected wave. Okay, and H1 is equals to incidence wave plus reflected wave in first medium. What about the second medium? The total electric wave in second medium is only transmitted wave, and here it is only transmitted magnetic wave. Clear it is. Okay, see what E1 is indicate. E1 is indicate the total electric wave in medium 1, which is EI and ER. Okay, we have to do the just addition. Okay, what is H1? So HI and HR. Okay, both are in the opposite direction. So actually see here, no need to take the negative sign. Okay, when we have to take the negative sign, when we have to take a vector quantity, then we have to take a negative sign. Okay, but just here we have to take the plus addition. Okay, what is E2? E2 means the total electric wave present in the second medium, which is only transmitted wave, and here only it is transmitted magnetic wave. Clear? Okay, so now the main thing is, now we have to apply our concept of boundary condition. Okay, now here where is boundary? Okay, now the question is, where is boundary? So by the definition of boundary, okay, this one is known as boundary. Boundary means boundary is always separate two different medium. So it's a medium 1 and this one is medium 2. So this one is known as boundary. Okay, so this line is known as boundary. So we have to apply our boundary condition for electric and magnetic wave that we have discussed in our last lecture. Boundary condition. Okay, here there are the two different medium 1 and medium 2. These are the two different type of medium. Okay, here is no conductor, no free space. Okay, it may be both a dielectric medium or anything. Okay, but both the medium are different medium. Both the medium contains sigma 1, epsilon 1, mu 1, sigma 2, epsilon 2, and mu 2. Here sigma value is not 0. Okay, permittivity is not unity, permeability is not unity. Okay, so these are the two different medium. Okay, so now we have to apply the boundary condition at this medium z is equals to 0. So z is equals to 0 is my boundary. Okay, so now what is the boundary condition? So at boundary condition, okay, we have to apply the boundary condition now. So at, we have to write in this way, at boundary the tangential component of wave are continuous. Okay, we have to prove that. Okay, at boundary the tangential component of wave are continuous. Which are the wave? Electromagnetic wave. Okay, at boundary tangential component, the tangential components of waves are equal or continuous. Okay, the tangential component of wave are continuous at the boundary. Okay, see here that we have discussed. Yes, here this one, the tangential component E1t is equals to E2t. Okay, the tangential component of waves. Okay, and here also in case of magnetic field. Okay, in case of the magnetic field, see here is, Here the surface current density is 0. Okay, if the surface current density is 0, again the tangential component are same, but the condition is if the surface current density is 0. Okay, here no current density is present. Yes, the conductivity is present, but no current is present at the boundary. Okay, so the current density component is 0. So we can say that the tangential component of both the wave are continuous. That means we have to write in this way: E1 tangential is equals to E2 tangential, and H1 tangential is equals to H2 tangential. Okay, so what is E1? E1 is EI plus ER. What is E2? It is ET. What is H1? HI plus HR. And what is H2? Which is HT at this boundary, at the boundary. Okay, so now we can write in this way: E1 tangential, which is EI at the boundary. Boundary means Z is equals to 0, so it is of 0, plus E1 is EI plus ER, so this ER is equals to E2. E2 means ET of 0. Okay, and second this one. Okay, so it is HI0 plus HR of 0 is equals to HT of 0. Okay, so this is just a simple boundary condition. Okay, now the main thing is, what is the value of electromagnetic wave at this boundary? Okay, when this wave is incidence, so what is its value at the boundary? Okay, so see here, what is EX0? EX0 is a maximum value of electric wave, and HY0 is the maximum value of magnetic wave when it propagates through the same medium. But see, when the wave is incident and when the wave is transmitted, when the wave is entering into the second medium, so this value may be changed. EX0 and EY0 value may be changed. It depends on this condition. It depends on this constant. Okay, so at the boundary, the values are maximum, which is EX0 and HY0, and when the wave is transmitted into the second medium, these values are changed. It depends on this material constant. Okay, so we can write in this way: in the boundary, EI0 has a maximum value, which is EIO. ER of 0 has a maximum value, which is ERO, and ET of 0 is the maximum value, which is ETO. See here, actually it's a EI of 0. Which 0? Z is equals to 0. Okay, so see, if we put here EI of 0, so it is Z is equals to 0, so it is only EIO, so to put EIO. Okay, so you can write in this also HIO. Okay, so it is HIO plus HRO is equals to HTO, but you can write this equation in this way also. It is EIO by eta 1 minus ERO divided by eta 1 is equals to ETO divided by eta 2. Why negative sign? See here, in this case, reflected. Okay, compare these two, HR of Z and HR of 0. Here instead of Z, I have to put 0. Put here Z is equals to 0. E raised to 0, 1. So this minus ERO by eta 1. Okay, clear. So these are the boundary. Okay, now I have to simplify this equation again. So if I have to simplify this equation, so this EIO minus ERO is equals to eta 1 by eta 2 into ETO. Okay, what is our ultimate goal? Our ultimate goal is to derive the equation for transmission constant and transmission coefficient and reflection coefficient. Okay, we'll continue. So I have to rearrange this term. Okay, so if you have to rearrange this term, so you can write in this way, this EIO. Okay, So now we have got two equations. First, equation A and equation B. Just do the addition of these two equations, equation A and equation B. Just do the addition of these two equations. Okay, so ER0 cancel out. So it is 2EIO is equals to ETO in bracket 1 plus eta 1 by eta 2. So ETO upon EIO is equals to 2 times eta 2 upon is it correct? Yes, it is correct. Okay, eta 2 plus eta 1. Okay, so finally we will get one equation. Okay, so what is said that? It said that it is a ratio of transmitted wave and incidence wave. Okay, it's a ratio of transmitted wave and incidence wave. So it is known as transmission coefficient. Okay, it is known as the transmission coefficient. Transmission coefficient say that how much portion of the wave is transmitted. How much portion of the wave is transmitted into the second medium. It is known as transmission coefficient. Okay, so here ETO by EIO it's known as transmission coefficient. Okay, and transmission coefficient is denoted as small tau. Okay, so small tau is ETO by EIO is equals to 2 times eta 2 upon eta 2 plus eta 1. So it is known as transmission coefficient. Okay, so here the small tau is known as the transmission coefficient. Transmission coefficient. How much portion of the wave is transmitted? It is known as a transmission coefficient. Okay. Now, from these two equations, I have to rearrange these two equations. Okay. Now I have to do. Okay. First, I do addition of these two equations. Okay. Now here, instead of ETO, I have to put this value here. Okay. Here, what is ETO? Okay, here ETO is equals to EIO plus ERO. I have to put this value. I have to put this. Okay, again here now I have to use again these two equations. Here ETO is equals to EIO plus ERO. I have to put this value here. Okay, and do the calculation to find out the reflection coefficient. Okay, so now EIO minus ERO is equals to, okay, this equation EIO minus ERO is equals to eta 1 by eta 2 into ETO. ETO means EIO plus ERO. Okay, so this EIO plus ERO, EIO plus ERO. Okay, so now do some mathematical calculation. Okay, so this EIO, so this 1 minus eta 2 is equals to ERO. Okay, 1 plus eta 1 by eta 2. Okay, so if we do some calculations, so this ERO by EIO, reflected wave by incidence wave is equals to eta 2 minus eta 1 upon eta 2 plus eta 1. Okay, so it is known as reflection coefficient. Okay, ER by EI. Okay, incidence wave and reflected wave. How much portion of the wave is reflected back? It is known as reflected wave. Okay, so reflection coefficient is reflected wave divided by incidence wave. It is a reflection coefficient. Transmission coefficient is transmitted wave divided by incidence wave. Is a transmission coefficient. Clear? Okay, it's not compulsory that you have to only consider electric field. You can consider the magnetic field also. Okay, we will get the same equation. Okay, so it is known as reflection coefficient, and the reflection coefficient is denoted using capital tau. So capital tau is ERO by EIO is equals to N2 minus N1 upon N2 plus N1. Okay, so here capital tau is known as reflection coefficient. Okay, so this is a reflection coefficient. Okay, so finally we have to derive the equation of transmission and reflection coefficient. Now we have to just derive the relationship between these two. What is the relationship between reflection coefficient and transmission coefficient? You can derive it by yourself. Okay, just put here plus 1. Okay, tau plus 1. So this plus 1. So this N2 minus N1 plus N2 plus N1 divided by N2 plus N1. So N1 and cancel. So 2N2. So we'll get this one. Okay. So what is the relationship between transmission coefficient and the reflection coefficient? The relationship between transmission and the reflection coefficient is 1 plus tau is equals to small tau. Okay. So this one is the relationship between transmission and reflection coefficient. Okay, now the main thing is what should be, okay, now listen carefully, what should be the minimum and maximum value for this reflection coefficient? Okay, so now see here, now the conclusion is important. Okay, so suppose for example we consider the medium 1 is free space and medium 2 is good conductor, and we know that by our knowledge we know that inside the good conductor no electromagnetic wave is propagate. That means whatever the wave is incident, okay, all the wave is reflected back. That means the transmitted wave is 0. The transmitted wave is 0. That means the transmission coefficient is 0. The transmitted wave is 0 means transmission coefficient tau is equals to 0. If transmission coefficient tau is equals to 0, what should be capital tau? Okay, so here all the incident wave is equal to the transmitted wave. Okay, so in this case the value of tau is maximum issued -1. Okay, so mode of tau is 1. Okay, in another case, suppose medium 1 and medium 2. Medium 1 is some material, medium 2 is some of the material, and all the wave which is incident and all the wave is transmitted here. There is no reflected wave. Then what happened? In that case, all the wave is transmitted. Okay, all the wave is transmitted. That means the transmission coefficient is 1. That means all the wave is completely transmitted. So tau is equals to 1. So in that case, capital tau is 0. So in that case, the reflection coefficient is 0. Okay, so using the transmission coefficient and the reflection coefficient, we can find out how much portion of the wave is reflected back and how much portion of the wave is transmitted. Okay, so actually what should be the minimum and maximum value of capital tau? Okay, so the capital tau, mode of capital tau is vary between 0 and 1. Okay, similarly small tau is also vary between 0 and 1. Okay, so these are the maximum value and the minimum value of reflection and transmission coefficient. Clear? Okay, so this one is the question. Derive the equation of transmission coefficient and the reflection coefficient, and what is the relationship between these two coefficients. Okay, so now in next lecture we will discuss about what is SWR, means what is standing wave ratio. Okay, and what is the relationship between standing wave ratio with reflection coefficient and transmission coefficient. Okay, thank you.